Hello, it's Keith from Kinvert. Sorry for the audio quality and the overall setup. I just switched to a Linux build and I'm just, been busy. But so anyway, I've got, the code's visible. I made an MNIST Autoencoder and I created a visualization out of it. So I'll go over the basics first. We've got the imports and model. And then we're doing the training here, and then this is some older visualizations. I haven't actually run these because I'm using the space for something else really, but I had a video that was actually working here to animate this, but then I eventually and I got this GIF working, but this is the new thing. I've got a video of this changing from the initial fuzz. So basically I'm inputting the test data for MNIST, and I'm doing 100 images, and so I'm taking those into the autoencoder, and then I'm training the autoencoder. And so at each step of the autoencoder, I'm running a batch size of like 512, and then I'm putting out the current guess, the current prediction, and those are going into this tiled image here, and then I'm just saving each frame. So right now I'm showing that one. Well, I don't want to run all this again, but I could show like so plt.imshow. Hopefully you guys, you can see that. And then it's going to be blends. That's just what I called it, and I could go with 0, and then it should be just fuzz. And then as you get further in, like at 50, maybe you'll start to somewhat recognize numbers there, and lower it seems like you'll see it more fuzzy. And so it's just basically saving the output, the predictions. And so anyway, and let me show you the finalized thing here. So you can see right now it's showing the kind of finalized numbers. There it is. So you saw it was so fuzzy, and then so for example, a lot of these, it seems to, like the zeros, it gets really quick, but a lot of these start off looking like a 9 and then they kind of change. But yeah, this is the output of the autoencoder. So I'm putting in, the test data. I'm putting in the 7 here, and then I'm just doing my prediction for each, not even for each epoch, but for each step. And I'm only stepping over 512 batch size right now. And then at each of those steps, I am dumping out the predictions, storing it in probably a NumPy array or maybe just an array, and then at the end of this I can process it into this. So at this point I guess I'll just go through the code. This is still going to be changing. Probably when I link to this it'll be different, but I got a kid now and I really don't have time to polish things anymore like I used to. So yeah, my imports, I've got matplotlib, NumPy, TensorFlow, and I've got this working with my GPU. Then I'm just normalizing the data to get it to the float between 0 to 1. And then these I don't think I'm using right now. This is when I was making the GIF. So I've been doing slightly more and more complicated animations, and so these are the ones I was using when I made the GIF that I showed below. It looks black and white instead of the kind of blue and yellow. So the model, basically this is just an autoencoder, right? And it's going to a 7x7 at the end. Although in this case I think it's flat. I was doing another that was convolutional, but this seems to perform better and it's faster. So the idea was to have a 7x7 output, but this seems to be outperforming convolution so far. Maybe I'm doing something wrong. But the input shape, this is MNIST, so it's 28 by 28. Then I've got a 128 dense and then a 49 dense, and then that's what I'm taking as the input to the decoder. So the encoder is taking in the square image, flattening it, putting out the 49 flat. Everything's ReLU. And then here I'm bringing it in, going from the 49, and then the reason I've got the 784 here is to kind of match that size and get the same. I guess I'm not printing the model summary. Let me so let's see, enter, and then print what is it, the autoencoder dot summary, and then you guys can see this should print. And so yeah, I just wanted to kind of match the number of parameters for the input and output. Oh, it's not quite as close as I thought, but anyway. So that's the autoencoder. And then to zip them together to get this full list so it's not just kind of two things, I made this layers, and I just dumped these into layers, then I extended. It's basically like append, except I'm putting in lists. And so I've got the layers, and now I've got a list of layers, and I can dump that into the sequential. And so I've got kind of three models here. I have done other things where I've done things just with the encoder. I'll do another video on that. I did some stuff where I did latent space, and I made images kind of blend into other images. Let's see, does this tell me how long I've been recording? Okay, so only 6 minutes so far. So yeah, I got the summary. Okay, so this is where some of this is happening, is in this callback. And so we've got on batch begin, and I did that so that we can get kind of the fuzziest initial guess. And so I'm just making this prediction history, and I'm just dumping out the actual model prediction. And so here you don't need to name the model because it's just self.model. Here is where you're naming the model right here. And so I'm using the autoencoder. That's the full model with the decoder and the encoder put together. And so yeah, on each not, is it on batch? Yeah, on each batch. So it's on each batch rather than each epoch. Okay, and then it's dumping out the prediction. And I did this because if I go on the epoch, by the time it gets through a full epoch, it already looks good. And so I wanted to show the fuzzy state. And I could get more frames if I ran this down to 256 or something like that, or kept shrinking this down. I could get a longer duration of when the images are very fuzzy. Here's where I'm calling the callback. And so again, this is TensorFlow. So I'm normally when you're doing MNIST, you're trying to do the classification, and so you're bringing in the originals. Now, a lot of people would call this X train, is what this would often be called, and then this would usually be Y train. The reason I went with X original is LateLab been doing a lot of data augmentation, and I've really been manipulating that a lot, and so I've been using X original now. Just because I'll do the training on data that I really messed with. Validation split of 10%, verbose just to get this, and then the evaluation is just to see, it's further evidence of if I overfitted, and so a 0.023 isn't great. Really I like to see when I'm doing this and actually trying to get clear images, I'm really trying to get like a 0.008 mean squared error or less. But in this case, I'm just trying to get fuzzy images and show how they slowly develop. This is how I was showing, and I could make a video of this later maybe, but basically this is showing how a single digit goes from fuzzy and just slowly becomes more clear. This one is when I was doing my initial animations and getting this to play, and then I was able to get it to play into like an HTML5 video. And then I was doing this way to make GIFs, and here's the result. Like I can load the image, and so you can see it working. But this is what I did for the past hour or whatever. So I'm importing OpenCV here, and that should be relatively easy to install. You can just run like pip, and you'll do the OpenCV-Python one probably. Now also the option is to build it from scratch from the source code. In this case I still haven't done that because I'm trying to get it to work with the GPU, and it's being really finicky. I'm on a Linux build. It's TensorFlow, so it's really hard to get all the versions to match, and I just haven't gotten OpenCV to build from source just yet. But anyway, so I just installed it with pip, did the pip install. So IDX, I'm not actually using this right now, except for just giving some dummy values out. But basically, Here's that full prediction history. It's just that huge history of basically every single batch and taking out all of the guesses. All like 10,000 or whatever guesses are in here. So this is a relatively large array. Multiplying it by 255 since it's coming in from 0 to 1. Well, it's not coming in from MNIST, TensorFlow's MNIST dataset. That's 255, but I divide it so that I can train, and now I'm bringing it back to 255. And then I'm doing the uint8, so I don't want to be bringing in floats to these other things. They don't like it, so I'm doing uint8. Sanity checking the sizes. Those will be gone probably when I don't know, maybe I'll leave them when I'm kind of showing off the Jupyter Notebook online. But you can see that there's a total of 212 frames. So basically, for each epoch, there are 106 batches based on the batch size of 512. And if we do the 512 by 106, and that's 54,000. I might be mistaken here. I'm not going to talk about that until I know for sure that I'm doing the math right. I might be wrong. Here's the 10,000 images. That's the 10,000 images. And then, yeah, that's the 212 basically steps that we're doing, the batches. And then let's see, so the images, so then I've got to go through and kind of slice this up. And this took me some trial and error to get. Now in this case, and this is actually from old stuff that I was doing here where I was doing it this way, when I was just outputting a single image. So this, I know it's not done, it's just it's hard for me to record. My son's usually not very occupied, and right now he is, so I just got to record. And so let's see, I'm doing the number of tiles, so that's the number of images that I want to show. So it's just a square 10 by 10. And then the total frames, I'm just doing 200. I could have done 212. And then here's the blends. Now this is still called blends because I just kind of pulled this from my other code where I was blending from one number to another, and I just liked the way that I had set this up to put all the data into one image instead of having all these individual images showing with all the axes. And so, yeah, so I'm basically initializing the image and saying, hey, there's a total number of frames, and it's 28 by tiles by 28 by tiles, right? And it needs to be uint8 or it's going to fail. So this is just going by the frame number. So it's like it's like nested loops. So it's not efficient, but I'm not trying to be with this. But yeah, so this is going through all 200 frames, and then this is going by the X and Y locations in there. So it's just stepping across the row, going down, stepping across the row, although that might not be correct. Let's see. Yeah, I think it is going by rows, and then, because sometimes with NumPy, it gets reversed, like first is the rows and then the columns, so it can be confusing with the difference between X and Y. So anyway, I'm just nested for loop going through this, and then I'm finding which specific image. So this is the frame index, because remember the size is the number of frames, and then all the images, and then the image size, okay? And so the first number is the frame, so that's the frame. And then I'm choosing which of these 10,000 images to show. And basically I'm just taking the first tiles times tiles images. And so in this case it's 100. And so it's I times tiles plus j. And then I've got to do this slicing so that I'm getting all of the rows, all of the columns, and just the single channel. And so that's what the zeros for, is to be pulling in that single channel. That's where I'm saying, hey, take that big array and just assign this particular image to that little chunk, and then that little chunk. Or I'm going backwards for the screen, aren't I? But anyway, so I'm just putting that 28 by 28 in there. It's an overall big array, and I'm just putting it there, putting the new image there, putting the new image there, and going through and doing that. And then this is just to give me, information so I can keep track of how far I am, And then this, there was a, like, OpenCV has documentation, and I found this. And so, yeah, we've got MP4V. This took trial and error, figuring out which one of these to use. And then, yeah, I'm putting out 30 frames per second. This is the size. And then, yeah, for I, am I using I? Yeah, I'm printing I. And then this is just going through each frame, and I'm just putting this out. So first of all, here's blend, okay, and I'm doing a convert color, and this is a single channel image, and it didn't like saving video as single channel, and so I'm doing this to give 3 channels that are the same. But then what I'm doing is I'm making the color map. So I'm taking that as the incoming image, and then I'm applying jet to that in order to get the blue is like a 0, and a deep red is like 255. And then I'm releasing the image, and then this is just showing me, hey, this is what was put out recently, and you can see that's the image. And so, yeah, 16 minutes, that's not bad. I'm sorry it's rambling, but I really didn't have time to prepare. Again, I got a kid, so I apologize. But yeah, you can see that the zeros seem to form up really well really quickly compared to others. And the other thing it seems to do is guess a 1 relatively quickly. And it likes to kind of, these will start off as a 9. A lot of numbers will start off kind of looking like a 9 when it's still fuzzy. But I don't know, maybe that's a 9 or a 4, I can't tell. Again, I didn't train this down to a really low mean squared error because I really wasn't trying to do that yet. I have done it, and I've got below like a 0.007 a couple times, and I could go further if I wanted to run it overnight, but I'm just, this is just, you know, me practicing, and I'm not trying to actually really do this in depth. But yeah, so that's the result, and I'll let that keep running a bit. We'll find out how bad the audio quality was. Probably pretty bad when I rewatch this, but okay, yeah, we'll let it run a few more times. If you got questions, let me know. I will. I won't be able to link to this probably right away. That said, though, I don't even know when I'm going to upload this or if I will. I think I went over basically everything. Yeah, some stuff that I didn't use in this run. Relatively simple model. This is just TensorFlow, just spitting out red stuff. If I do it a second time, usually it won't show up. And then, yeah, this is how I trained. It took 46 seconds. I've got a 3070 Ti. And so, yeah, that took like a minute and a half to do this. It's way, way faster. I can run up this to like, you know, 2048 is easy, 4096, or what is it? 2096. What are the numbers? Now I'm embarrassing myself. My son's sick, and I really didn't get to sleep much. 4096 and then 8192 before I do it. 8192. Okay. Yeah, sleep deprivation is real. Okay, atom, mean squared error. Yeah. And then, yeah, eventually I'll probably try to do a similar I'm not going to be able to do this from scratch, like making the video. But I'll probably end up writing this from scratch too in like NumPy to just do the autoencoder. That'd be a fun one. Yeah, I've got a lot of little projects I'm planning on doing, and hopefully I'll be able to find time to record some of them. But it's going to require me to not edit video, and so the videos are going to turn out very poorly, and I apologize for that. So it is what it is. Okay. Again, if you have any questions, just ask in the comments if I load this to YouTube. And yeah, hope that helped. So Keith from Kinvert, hope this was helpful, and I'll see you guys later. Bye.